Welcome to the visualization overview. My name is Brett Champion. I'm a kernel developer here at Wolfram Research, working mostly on visualization. So for version 9 of Mathematica, we have added legends to every visualization function that we know about. I say that we know about because there have been at least a couple that have snuck in that I wasn't aware of until a couple weeks ago. So I need to double back and make sure that we cover those as well. So here is list line plot. We've got two data sets, and we say that we want plot legends, and we get nice, beautiful legends. Yay! So things like list line plot aren't terribly difficult. Density plot gets a little bit more complicated because we have to know what the z range is. But we've got that as well. And so it is correctly picked up. I don't think the tick labels were especially magnified by my notebook magnification setting, but the color bar is going from -1 to 1, matching the range of the function that we're plotting. And an important part of our legend design is that there are going to be cases where what we have built in isn't going to suit your needs. And so we've added some constructors to make it easy to generate your own legends for your own purposes. And so we have 4 main generating functions. They fall into 2 categories. The first category are basically category identifiers. So these are swatch legend, line legend, and point legend. And if I take, say, the general syntax for these is a list of styles and a corresponding list of labels. And then there's a small set of options that goes along with this. The number of options is greatly reduced from the old plot legends package. And rather than being options of each of the visualization functions, the options get pushed down into these constructors. And Min will give you all the gory details of all the things that you can do with these constructors. The second constructor that we have is for color function types of legends, and it's named bar legend, and it handles both the case where we have a continuous gradient or a segmented gradient like you might use for contour plot, for example. So moving on to units, we're in the process of building in support for units to the visualization functions. I will not promise full coverage of all 100 visualization functions by the 9.0 release, but anything that we don't get to will be at the top of the list for the next version. So here we have, as an example, some temperatures that I got from weather data for the airport down the road, the mean temperature for every day in September of this year. And this is coming back in Celsius by default, and so I've wrapped it in quantity and said that these are Celsius, and you can see that we have, they have little tooltips on them that the unit system puts automatically for saying that this is 24 Celsius. So just evaluate that real quick. And there is our list plot working on the data with units automatically. If you specify axes label goes to automatic, it will put the, it will annotate the axis with the appropriate unit. That also has a little tooltip to clarify what that syntax or what that notation is. Celsius is probably fairly clear, but sometimes there are others that are less so. If I had Celsius and Fahrenheit, let's see, so that day was really cold. assuming I can spell Fahrenheit. Good thing I took German in high school. Helps if I change an actual item in my data set. So here we still have, everything's Celsius except for this element at the end, which is in Fahrenheit. So now we'll plot it, and it goes way off the scale. Like I said, so our data is at this point mostly in Celsius with that one Fahrenheit outlier. Not sure what was happening with the weather station that day, but okay. If the unit that the data is in is not the unit that you're interested in, there is a new option called target units, which allows you to specify what the unit should be. So in this case, we say that we want it to be in Fahrenheit, and it converts all of the data from Celsius into Fahrenheit and plots that. So now that we have target units, I'm going to try yay. And we have days. And if you don't want, so this is still going to have the tooltip. If you don't want the tooltip, then what version do I have for the unit stuff? Quantity form. Does quantity form have documentation in this build? You want to take bets? Well, you could put none, but that's not interesting. That's what the default setting for axis labels is. So, so let's say I want the abbreviation. Oh, that's not what I wanted. I want that up there. So now we have Fahrenheit versus days, and days is just a string, and Fahrenheit has been converted into a quantity form, so it's abbreviated, but it doesn't have the tooltip. So that's one way to specify that you have axes labels without the tooltip. So here are a couple of examples that I've liked. So possibly I'm stealing this one from Min's talk. So here we have various units, all units of length, and we've just sort of mapped quantity across them to create 1 meter, 1 foot, 1 inch, whatever. And we're showing a bar chart, and in this case we've said that we want the target units to be meters, and we've added a nice little legend, and you can sort of see how all of these units of length compare in relation to each other. And the other example is this one, which is, I wanted something that was a bit more real world types of stuff. And so I was curious about heights of people in different countries around the world. And so I found this handy website called Wikipedia that has, this website has a table that is not especially clean in terms of how well it's filled out and this sort of thing. So I'm going to bring up a browser so you can see this table firsthand. It's an excellent example of real-world data. It required much data processing to get at the things that I actually wanted. Scroll down to it. Okay, so here is the table. And so we have country, an average male height, an average female height, the ratio between the two on average, the sample population range. So some of them are broken down to, like, young adults versus everybody versus whatever. Different methodologies, what years it covers, and the source. And so basically, yes, share of population over 15 that was covered. And as part of the, cleaning up of this data and wanting to get only reasonable data, I was looking for countries that had, the heights were actually listed, and that they were covering at least 90% of the adult population, for some definition of adult. And so, there's some amount of processing and some parsing. In particular, one thing that's kind of fun is I was taking the heights as strings, and this part of the table is relatively uniform in terms of how it's structured, and so I was looking for number followed by m, and anything after that I was throwing away, and then I was parsing the m. And whereby I was parsing the m, I mean I was feeding it into quantity to let it parse it for me. And by the time we're all done, we get down to this data set of things that met my criteria of having a large enough portion of the population sampled that I had some trust, some faith in the validity of the data. And so here are the countries that I got as a list, and here we are creating a bar chart. Let's see, how big is that? Oh, make this bigger. And so we're plotting the heights, which are basically pairs of quantities for male and female. And then I'm labeling the x-axis with the country for each of them. The colors are coded in a semi-traditional form. And I've used the labeling function to give each bar a tooltip that contains the height in meters, and also I've converted the height from meters into feet and inches. So if we look at the US, the tooltip is going to be incredibly small. The average male height, according to that table, is basically 5 feet 9.5 inches. And the female height is a little bit less than that, basically about 5'4". And so you can see the Netherlands are relatively tall compared to everybody else, and Bahrain is relatively short compared to everybody else. But it was an interesting experiment to sort of get data out of the wild and plot it without stripping away too much information. So the next thing I want to talk about are gauges. So here we have the three main kinds of gauges that we have, or the three main basic gauges that we have: angular gauge, horizontal, and vertical. I've made the argument for each of these to be dynamic, and they're just going from 0 to 1 by default. The dynamicness means that I can click on one of the needles and drag them all around and they all update each other. Then we have three specialty gauges. We have a clock, which isn't dynamically updating right now. I can wrap dynamic around it and it will. And I can see how much I'm running out of time. And then we have a thermometer, which is probably fairly familiar to most people. And then we have this one in the middle, which I'll make a little bit larger. And this is called a, we're calling this bullet gauge. And it takes, so most of the gauges are sort of taking one value by default and displaying that. This one is actually taking a bit more than that. The main value is our current, The main value is represented by this red bar down the middle. And then we have some sort of reference or target that we are curious to see where that refers to. And then the background is shaded according to different ranges of the data that we're interested in. So a typical example for this sort of thing would be, like say, sales numbers. You know, we're selling product X, and last year we sold 80,000 of them, and this year so far we've sold 42,000, and you know, anything above 75,000 is really good for our company, and anything below 50,000 is going to, you know, start causing hard times for people. And so this is a way of sort of showing all of that information in one condensed display. Why isn't the clock gauge updating? It shouldn't need refresh. It's an interesting question. I'll have to take a look at that. It's trying to give me more time. And so one other thing is that because the gauges are able to be dynamic, there are things that we can do with them, like use them inside of manipulate. So here we have something that's not quite fitting on my screen, so let's see if I'll probably resize as soon as I drag something. No, it remembered. So I can use this as a control within manipulate, and it's nice and responsive.